Would you like to live on Mars? What would it take for you to leave Earth and settle on another planet? How would you cope with the challenges and risks of living in a harsh and alien environment? Hello and welcome to Curiosity, where we explore fascinating and interesting topics about everything. Today, we are going to talk about, what are NASA's plans for Mars migration? Before we begin this episode, please check the previous episode for the information about characteristics of Mars, the challenges and risks of human migration to Mars. Despite there are many challenges, Mars has always fascinated humans and inspired many visions of exploration and colonization. For centuries, people have observed Mars through telescopes and imagined what it would be like to visit or live there. In the 19th and 20th centuries, many science fiction writers and artists created stories and images of Martian civilizations, wars, invasions, and adventures. But science fiction is not enough for some people who want to make Mars a reality. In the 20th and 21st centuries, many scientists and engineers have been working hard to develop the technologies and capabilities needed to send humans to Mars. The first step was to send robotic probes and rovers to study the planet from orbit and from the ground. The first successful mission to Mars was Mariner 4 in 1965, which flew by the planet and took 21 pictures. Since then, more than 20 missions have been launched by various countries and organizations. Some of the most notable missions are as follows. Viking 1 and 2 in 1976, which were the first to land on Mars and conduct experiments. Pathfinder in 1997, which deployed the first rover Sojourner. Spirit and Opportunity in 2004, which explored different regions of Mars for several years. Curiosity in 2012, which is still operating today and has found evidence of past habitable environments. Perseverance in 2021, which is searching for signs of ancient life and collecting samples for future return. Ingenuity in 2021, which is the first helicopter to fly on another planet. These robotic missions have provided us with valuable information about the history, geology, climate, atmosphere, and potential habitability of Mars. They have also paved the way for future human explorers who will face many challenges and risks on their journey to Mars. One of the biggest challenges is how to get there safely and efficiently. A trip to Mars takes about 6 to 9 months depending on the launch window and the trajectory. During this time, the crew will be exposed to cosmic radiation, microgravity, isolation, stress, and boredom. They will also need to carry enough food, water, oxygen, fuel, and equipment to survive and perform their tasks. Another challenge is how to land on Mars safely and accurately. Mars has a very thin atmosphere, which makes it difficult to slow down and control the descent of a spacecraft. The landing site also needs to be carefully chosen to avoid hazards such as rocks, craters, dust storms, and high elevation. A third challenge is how to live and work on Mars for an extended period of time. The crew will need to adapt to a new environment that is very different from Earth. They will need to deal with extreme temperatures, low pressure, high radiation, dust, and reduced gravity. They will also need to maintain their physical and mental health, and their social and emotional well-being. They will also need to conduct scientific and engineering research to learn more about Mars and its resources. NASA's vision for human exploration of Mars is not just to visit the planet, but to stay there for longer durations and eventually establish a permanent settlement. To achieve this goal, NASA is developing the capabilities needed to send humans to Mars in the 2030s as part of their Artemis program, which aims to establish a sustainable presence on the Moon before sending humans to Mars. NASA's plans for Mars include sending multiple missions to the planet to establish a habitable environment and to support human exploration and research. Some of the key elements of NASA's Mars architecture are as follows. The Orion spacecraft, which will carry the crew from Earth to lunar orbit. Orion is designed to withstand the harsh environment of deep space and provide a safe and comfortable habitat for the astronauts. Orion can accommodate up to 6 crew members and has a service module that provides propulsion, power, thermal control, and life support systems. Orion has already completed uncrewed test flights. The Gateway, which is a small outpost in lunar orbit that will serve as a staging point for deep space missions. The Gateway will consist of several modules that will provide docking ports, living quarters, communication systems, scientific instruments, and refueling capabilities. The Gateway will enable access to the entire surface of the Moon and allow for flexible and reusable missions to Mars. The Gateway will be assembled in orbit using commercial and international partners. The Space Launch System, which is a powerful rocket that will launch the Orion and other payloads. SLS is the most capable rocket ever built, capable of delivering more than 130 metric tons of payload to low Earth orbit and more than 40 metric tons of payload to lunar orbit. SLS will enable faster and safer trips to Mars by reducing the number of launches and transfers required. The Mars Transfer Vehicle, which is a propulsion module that will carry the Orion from lunar orbit to Mars orbit. MTV will use solar electric propulsion, which is a highly efficient and low-thrust propulsion system that uses solar panels to generate electricity and ion engines to accelerate xenon gas. SEP will enable longer and more flexible missions to Mars by reducing the amount of propellant needed. MTV will also provide communication and navigation services for the Orion during the interplanetary cruise. The Mars Habitat, which is a module that will provide living and working space for the crew on the Martian surface. MHAB will be pre-positioned on Mars by an uncrewed mission before the arrival of the crew. MHAB will have a pressurized volume of about 50 cubic meters and will accommodate up to 4 crew members. MHAB will provide life support systems, communication systems, scientific instruments, exercise equipment, and personal quarters for the crew. MHAB will also have an airlock that will allow the crew to exit and enter using their spacesuits or rovers. These are some of the main components of NASA's Mars architecture, which will enable humans to travel to and live on Mars in the near future. Of course, there are many more details and challenges that need to be addressed and solved before such a mission can become a reality. NASA is working with many partners to develop and test the technologies and systems needed for human exploration of Mars. NASA is also engaging with the public and inspiring the next generation of explorers and innovators who will make this vision a reality. But going to Mars is not enough for some people who want to make Mars more like Earth. This is where the concept of terraforming comes in. Terraforming is the process of creating an Earth-like or habitable environment on another planet. Terraforming Mars would involve changing its atmosphere, climate, and surface to make it more suitable for life. Some of the possible methods of terraforming Mars are as follows. Releasing greenhouse gases from the Martian surface or from asteroids to thicken the atmosphere and warm the planet. Melting the polar caps or importing water from comets or moons to create oceans and lakes. Planting genetically modified plants or microbes to produce oxygen and reduce carbon dioxide. creating artificial magnetic fields or satellites to shield the planet from solar wind and radiation. Altering the rotation or orbit of Mars to increase its day length and solar energy. However, terraforming Mars is not an easy or quick task. It would require a huge amount of resources, technology, and time. It would also raise many ethical, legal, and social issues. For example, is it right to alter another planet for our own benefit? What if there is native life on Mars? Who would own or govern Mars? Terraforming Mars may seem like a distant and unrealistic dream, but it is also a fascinating and inspiring one. It challenges us to imagine what kind of future we want for ourselves and our descendants. It also motivates us to explore and understand our own planet better, and to appreciate its beauty and diversity. Terraforming Mars may not be possible using present-day technology, but it may be possible using future technology that we have not yet invented or discovered. The only way to find out is to keep exploring and learning. That's all for today's episode. Thank you for watching Curiosity. If you enjoyed this video, please like and subscribe for more content like this. And don't forget to share your thoughts and questions in the comments below. Until next time, stay curious.